So today we are here to discuss the topic control charts for the attributes. Now control chart for the attributes, the inspection result based on the classification of product defectiveness and the acceptability on the basis of prescribed specification. Now, as we discussed earlier, when the suppliers supply the lot onto the manufacturing site, now the manufacturers have to take certain decision. The decision will be in the form of yes or no, means acceptance of lot or the rejection of lot. So for the acceptance and rejection, what the manufacturer basically do, he basically count the number of defects. So here it mentioned is the result based on the product effectiveness and acceptability on the basis of prescribed specification. Prescribed specification means that the product will lie within the certain limits. Now, what are the certain limits? The limits which are defined on the basis of on the upper base, that is known as upper control limit, on the lower base is known as the lower control limit. So the product or the process must be lie between these two limits for the acceptability. Now the representation in this way is known as attributes. Okay, so attributes type of data are those data which can be counted. Okay, and how we can count the number of defects. So for this, various control chart for the attributes are classified below. First is the P chart. Now how you can define the P chart? P chart will calculate the fraction defective chart, and it is used for the percentage defective in a sample. Okay, what you will have to calculate? You have to calculate the percentage defective in a sample. How you can calculate? Just you have to take the ratio of total number of defects, which is to be divided by the total number of samples inspected. We have to discuss in a very brief just after this slide also. Okay, now we just move toward the C chart. Now here the sample is replaced by a single product, and what we have to do in the C chart, just you have to count the number of defect in a particular product. So here it is written as it is used to monitor the number of defects per unit. So what you have to do, you have to just define the defects in a particular product. Okay, now the third chart for the attribute is NP charts. Now what does the NP chart do? NP chart basically control chart of the defective items. P chart, the difference between the P chart and NP chart is P charts will just focus on the fraction defective or percentage defective, while whereas the NP chart will focus onto the defective items. Now we just take one by one these different type of charts. Now first type of chart is the P chart. Now for the P chart, as we already defined the product specification, a prescribed specification. So for the prescribed specification, we have to define the three type of limits. Now first of all, we have to define the center line. How you calculate the center line? P dash over here is written as total number of pieces found defective divided by the total number of pieces inspected. Okay, so in this way you can calculate the value of a P dash, which is defined as a center line for this P chart. Okay, or in the other word, P dash will also define as the mean value or the process average value. So in the next part, we have to define the upper control limit. How you calculate the upper control limit? It is given by the formula P dash plus 3 under root of P dash into 1 minus P dash upon N, where P dash is the center line limit. Okay, where N is the number of pieces inspected per day. Okay, similarly, like the UCL, lower control limit is also given by the P dash minus 3 under root of P dash into 1 minus P dash upon N. Okay, now we just clarify this thing with the help of some example. Okay, now take this example. The date will be given from November 1 to November 10, and corresponding to the dates, number of pieces inspected and number of pieces found defective will also be provided to you. And what we have to calculate in the P chart, we have to calculate the value of the fraction defective. Okay, so we just take the date November 1st, in which number of pieces inspected will be 300, and corresponding to the piece inspected, number of pieces defective will be 25. So how you calculate the fraction defective? Fraction defective is number of pieces defective upon number of pieces inspected on that day. So number of pieces defective is 25, and what the number of pieces inspected? 300. So this value will be 25 upon 300. Okay, similarly, this 300 upon 30 is the fraction defective of November 2nd. So 35 upon 300 is the fraction defective of November 3rd. Similarly, we can calculate the value of fraction defective up to November 10. Now the next step is just we have to sum the number of pieces found defective. And what will be the summation? We just sum up these values from November 1st to November 10. This value comes out to be 350, and how much, and the total number of pieces inspected can be calculated in this way. Yeah, either you do the summation, or just take the 1 day and multiply with the 10, because the number of date will be 10, and on the single day pieces inspected will be 300. So either you follow the summation way, or either you follow the multiplication way, the result will be same. Now, first of all, we have to calculate the process average value. How you calculate the process average value? T dash is total number of pieces defective, that is 350, upon total number of pieces inspected. Okay, the value will be 350 upon 3000. So this value comes out to be this. Now upper control limit is calculated with the help of this formula. So number of sample inspected is 300. Okay, so UCL value will be 0.1723. Lower control limit value comes out to be 0.0611. So what is our so what will be the next step? The next step is to draw these three limits on a graph. Okay. Now this is the graph for the P chart. On the y-axis, we have to denote the fraction defective, because as you see in the definition, basically the P chart is basically used to control the fraction defective, okay, or a percentage defective in a sample. So fraction defective will be marked on the y-axis, while on the x-axis date will be marked. Okay. Now see from the here, on November 1st, fraction defective will be 0.0834. Okay. So date November 1st sample is 0.0834. Okay. So for the November 2nd, fraction defective will be 0.1. Okay. So November 2nd defect will be 0.1. So similarly, we can calculate the value from November 1st to the November 10, and by simple joining these points, we obtain this type of graph around the process average value. Now, if any point exists above the UCL and below the LCL, such process will be out of control. Now, as you see from this graph, none of the point lie below and above the UCL and LCL respectively. So all the process for this sample will be in control. So in this way we can calculate the product. So in this way we can calculate the value of prescribed specification or three limits for the P chart. Okay. Now we move towards the C chart. So C charts, how can we define the C chart? C chart is basically used to find the number of defects per unit. Okay. So how you calculate the center line? Center line value will be given by C dash. C dash is total defects in all the items inspected divided by total number of items inspected. Okay. UCL is C dash plus 3 under root C dash. LCL is C dash minus 3 under root C dash. So we can understand this with the help of some examples. So let us consider the C chart for the following example. You have done the casting for the job number 1. On particular job number 1, 2 defect will be found. On job number 2, 4 defect will be found. Similarly, you have gone through the casting for the 10 different products, and corresponding to the number of products, corresponding to the number of the product, number of defects will be defined. Okay. Now what we have to do, we have to just sum this number of defect values. Okay, some summation comes out to be 37, and total sample will be number of 10. So how you calculate the C dash? C dash is number of defects found divided by total number of samples. Okay, so C dash is 37 upon 10, that is 3.7. So UCL will be C dash plus 3 under root C dash. C dash is 3.7. So put this 3.7 plus 3 under root 3.7. The value comes out to be this. While on the LCL, this value comes out to be negative. So what we have to do, likewise, if you see this problem, the number of defect for a corresponding product will be 0. Okay, none of the sample value will exist the value negative. So for the negative value, we have to take the minimum value correspond to the 0, because the defect will possess a certain value, not a negative value. Okay. Now what the next step is? Next step is to draw the C chart with the help of these three limits. Now what will be provided on the y-axis? On the y-axis, we have to give the number of defects, and what on the x-axis, we just define the casting number. Okay. So let me see. for the first casting number, for the correspond first casting number of defect found to be 2. Okay, so for the first, number of defect will be 2. For the second, number of defect will be 4. So second number will be 4. Similarly, third up to the 10 sample, and simple by the line joining we obtain this type of graph. Likewise, in the P chart, just overwritten here that all the value of C lies within the control limits. Therefore, the process is under the control because uh, as you see from the graph, what you conclude is that none of the point exist above the UCL and below the LCL. So all the process producing such samples will be in control. Okay. Now we move towards the NP charts. What we have to do for the NP charts? Just we have to go for the what we have to do the just we have to go for the number of defective. So the first step is to calculate the three limits. Okay, and how we calculate three limits? First is the P dash. P dash is number of defective upon sample number into number of size. Summation D upon NK, where central line can be defined as NP dash. UCL is NP dash plus 3 under root of NP dash into 1 minus P dash, whereas LCL is NP dash into NP dash minus 3 under root NP dash upon 1 minus P dash. Okay. So we just understand this chart with the help of example. Now let us consider the following example. Here the 20 sample of size 20 each were inspected. Following are their results. Okay, so we just take the sample number 1, in which sample size of 20 will be inspected, and corresponding to 20 pieces 0 defect will be found. Okay, similarly for the sample number 2, 20 pieces were inspected, and out of 20 pieces 2 pieces were found to be defective. Okay, similarly up to the 20 of 20 size each, you will found the defect corresponding to the sample numbers. Okay, now what we have to do is we just have to sum the number of defect. Okay, summation of number of defect comes out to be 25. Number of samples will be 20, sample size is 20. So we just go for the formula in which P dash will be calculated as number of defects is 25. Okay, upon sample number. Sample number is 20. Sample size is again 20. So 25 upon 20 to 20 comes out to be 0.0625. How you calculate a central line? This comes out to be NP dash. The value comes out to 1.25. Similarly, calculate the value of UCL. UCL comes out to be 4.50, whereas LCL comes out to be negative. So likewise in the C chart, we just take it equivalent to the 0, because the negative defect will not exist for a particular sample number. So next step is to draw the NP chart, and what you have to draw on the y-axis, because the conclusion is number of defective on a particular sample number. So see, if sample number 1 exists, corresponding to it number of defect will be 0. So sample number 1 corresponding defect is 0. Okay, for the number 2, how much is defective? Is 2. Okay, for the 2, defect is 2. Similarly for 3, defect is 1. Okay, for 3, defect is 1. Similarly for the 20 sample, you just plot this graph, and from this graph we basically conclude that none of the point exist above the UCL and below the LCL. So each and every samples lies inside of the LCL and UCL. So therefore the process is under the control. So from the above, we just discussed the various charts for the control charts for the attributes. Okay, thank you.